Hey folks, in this video I want to introduce the concept of abstract data types. So abstract data types, you've probably already heard the term before. So in previous classes you've seen things like, for example, stacks and queues, and probably lists as well. Well, almost certainly lists as well. Now these things, right, they use maybe two different terms to refer to these. One is abstract data type, another one is collection. Collection I'll be using from time to time. A collection is somehow a little bit different than an ADT. A collection is basically like a class, right, that's a container, right? So it's like, well, a stack is a collection because I put stuff into it, right? I put all sorts of elements into it. I put it, same thing with a stack, right? Or same thing with a queue, right? I put a bunch of stuff into it. Again, it's a collection. But then, right, we have this term of ADT. So ADT is kind of a little bit more specific. What ADT is basically referring to is a type with some operations associated with it. So it's a complex type. So it's something like normally, right, we have things like integer, double, and we have plus, minus, right, all these kind of standard things defined. Well, if I have some sort of a object, right, that has the sense of encapsulation, has some behavior associated with it, I'll say it's an abstract type. This is sort of what you've heard up until now. Now for us, we're going to have even more strict definition of abstract type. So we're going to say the following: an abstract data type is a data type. Well, it's represented in terms of operations, and whose internal representation is hidden. And this is the key bit here. So this is something that basically people don't explicitly state. People say things like, oh, an ADT is implemented with a class, and a class should be well encapsulated, send a story. That's okay, but it's merely okay, and we can do better. Okay, so our rule here, right, and this is our number one rule, this is the only thing that matters, right, is that our internal representation is hidden. The idea is that our ADT should represent a complete decoupling between the interface, right, of some behavior and the actual underlying representation for it, right? So how do we get it done is completely separate than what we're actually doing. Why is this a good idea? It's a good idea because it makes elements much more interchangeable in our system, right? So if I build a class and exposes certain things to the outside world, right, certain behaviors, well, if I'm not, if I don't care about it, right, if I all of a sudden, don't bother to hide the internal representation, what happens is my interface, right, somehow that, the stuff underneath, right, kind of seeps through. And then, tomorrow when I find out that, oh, this class is no good and I need to revise the interior and I need to use some different way to store data, then I have to change the interface that object is exhibiting to the outside, right? I have to change the functions that it makes available. This is horrible, right? So you think in terms of maintenance. All of a sudden I have to redo all my system, right? So what I want is I want things to really be really encapsulated, right? I want to completely decouple the internals from what's being displayed outside, right? What are the pieces of functionality that are being displayed outside? I want to absolutely decouple that. So that's going to be our focus here, right? That's our number one goal, right? We're going to be really stress this again and again and again. All right. So adding an emphasis here, right, on abstraction, right? I want to have this, this decoupled thing, right, where it's like, well, this is, a black box, right? I don't have to worry about anything that's inside of it, right? I only care about what's outside, right? And I'm never going to be impacted by what changes inside that black box. All right. So yeah, basically, right, the only thing you care about is what's in the interface. And typically, right, an interface could be literally an interface in Java. It's also just think of, a bunch of function signatures or method signatures, and then some API documentation to go along with it. Typically, you need both, right? If you have just a list of methods, it can be a little bit hard to use those, right? Because you don't really know all the behavior that might be involved. You need to also have some, documentation that defines, this is, the possible behavior that my different methods could exhibit over time. All right. So one question there at the very end, right, to ask you guys for you to think about for a second is, in practice, should we completely ignore the implementation? So think about that for a second, right? Pause the video, and then we'll discuss it. All right. So should we, ignore it in practice? Well, so this is a little bit of a sticking point. So up top, right, this is sort of the hope and the dream, right? In terms of, maintenance, right? In terms of making things that, it's, easy to interchange components of my system. This is the world that I want. Unfortunately, I have one problem, and that is the problem of performance. Because I can build something that has the same signature, same method signature, same API documentation, right? All that would be identical, but which has different performance. So I could have, some implementation A that has, performance big O of n versus another one B, which has big O of n squared. And that isn't directly encapsulated in that function signature, right? Maybe I could mention it in the API documentation, but it doesn't actually influence the behavior, right? And behavior is what we have to care about here. And so this is where we get into trouble, right? We get into trouble in things that aren't, clearly defined, right? They aren't specifically defined somewhere. And so this is one thing we do have to care about, right? We do have to care, right, that implementations are somewhat fast. Even though they might be equivalent in terms of functionality they provide to our system, do they do it with the same performance? Because for a lot of applications, performance really matters, right? So that's one thing we definitely have to care about. The other thing here, right, that we sometimes have to care about is also like, and this is specific to Java, is like exceptions, right? So there are some things, right, that maybe can leak out of our abstraction, right? So even though I have a black box, well, in Java, I could throw an exception inside, and that exception could be anything, right? And all of a sudden it pops out outside world, somebody else has to deal with it, right? Again, this is something that might not be properly captured inside of our method signature or inside of our API documentation. So these are two areas where we kind of have to be a little bit careful. All right, so in this video, right, we've kind of talked about ADTs, right? We've really stressed on this internal representation thing. That is the core difference, right? Make it a true black box.